trigonometric functions. Right, so we again are just going to focus on the primary functions, or those basic functions which are sine, the cosine, and the tangent. So let's remind ourselves, when we're looking at the inverse of a function f, we saw that f has an inverse if and only if f is 1-to-1. So it is 1-to-1 and also onto. So this is what we know
Recording in
from what we
progress.
have done before, that a function will have an inverse if it is both 1-to-1 and onto. Now, the function y is equal to sine x is not 1-to-1. So we try to make this function 1-to-1 so that it has an inverse. Otherwise, if it is not 1-to-1, it will not have an inverse. Now, for us to be able to do this, we restrict the domain. So let's restrict the domain to the interval minus pi over 2 to pi over 2. So that's what we are going to do in order for us to be able to define the inverse of this particular function. So in this, you see, let me just draw, not here. So let me just draw the function, or rather the sine curve. So remember that your sine curve is a function that looks something like this. The sine curve is that particular function. So I'll just give you that sketch. Of course, it must be a smooth curve. Right, and so we have also that part on this side. Now, this is the graph of y is equal to sine x. So what we mean by restricting the domain, so we have 0, here you have pi, and that to be 2 pi. So the period is 2 pi, and so this will have negative pi, and then negative 2 pi. Right, so in between here, we have minus pi by 2, and also pi by 2. So we are saying that we are going to restrict our function in this interval, which has pi by 2 and negative pi by 2. So in this case, if you also know other ways of showing that a function is 1-to-1, you can see that we are going to get a 1-to-1 function. So we are going to restrict our domain in that range. So just put these dotted lines. So our interest now will be this function that we have here. So that is the function that we are going to work with in this particular domain. Right, so once we do that, then of course, this function will be equal to, is 1 to 1. So in the restricted domain, the sine function is 1 to 1. We can define the inverse. So the inverse of y equal to sine x. Now, in the restricted domain, is a function that assigns every x. So I'll just say assigns an element x in the range -1 to 1. So remember that the function value here is 1, and then you have -1. Right, so the inverse will assign an element in the range -1 to 1 to a unique element. So in that case, we have a unique element, let's say y, in the range -π/2 to π/2. So that's the range and the domain of actually the function that we are going to define. And this will be such that x is equal to sine y. So the inverse of the function then will be defined as follows. So let me go to the next board. So we have the inverse given as follows. Y is equal to sine x. So we'll write it as y is the sine inverse of x.
Excuse me, sir.
Yes, please.
I'm kindly asking if you can repeat the previous screen.
Okay, I'll do that. Just a minute. So we
Aye.
can also write this as y is equal to arcsine of x. So this is what we would denote the inverse to be, and that's how we are going to define it. So in other words, we are saying the following, that y is equal to the inverse sine of x if and only if x is equal to sine y. Okay. So I've gone back to the previous slide for you, and I'll just remove the parts I don't need. So please let me know when you are ready so that we move on.
All right, sir. You can move on.
Right, so this is our function that we are considering, and in this interval now, we can define the inverse of this particular function. So that's the inverse, and of course, we can draw actually the inverse function, but I think for this course, we are not interested in such. So the only thing that I want you to do or to know is that y inverse, y is equal to the sine inverse of x is not the same as 1 over sine x. So those are two different functions. The other one is the reciprocal of sine x and not the inverse of sine x. And of course, you know what the reciprocal of sine x is in terms of the secondary functions for trigonometry. Right, so the graph, that's the first note. The second note that I can give you is the following. So that's number one. Number two, we have that the graph of y is equal to the sine inverse of x is a reflection. So we can look at it as a reflection of the function y is equal to sine x. So we are reflecting this in some line, and that line is the x-axis. So in this case, sorry, not the x-axis, but the line y is equal to x. So that's how these two functions are related. However, what you notice is that the domain now changes to the range, and the range changes to the domain. So if you remember what we used to do when we are finding the inverse of the function, we are first interchanging or swapping the variables x and y, and then make the other variable a subject. So this is exactly what we have done in this particular situation. So the line y is equal to x, we use a different color, will be this particular line. I hope I can draw it nicely. Right, so that's the line y is equal to x. And now we are saying that if you want to draw the inverse of sine x, then you just reflect the curve in this line. So you can see that if you are to reflect this, what we are going to get is the following. We look for a different color. Right, so if you reflect that, you are going to get that particular side. And also here, you are going to get what we have. So this will be a shape of the graph of y is equal to sine inverse. However, the only thing you need to do now is to interchange the intervals. So you have one, rather -1 here and 1 there. And there you have pi by 2. And here you have -pi by 2. So that is how these graphs are related. But like I said, we are not so much interested in the graph of the inverse function. Okay, so is there any questions so far?
Yes, sir.
Yes, please.
Writing the inverse of the function, you said that it is not equal to 1 over sine x. So what if you write, instead of writing y is equal to sine x, you write y is equal to 50 sine x?
You write y is equal to?
50 sine x.
I didn't hear. Is this 50 or what?
shift yapa calculator. The
Shift.
shift, yes.
But we are not using calculators here. Why do you want to use shift? What are you shifting?
Showing it is an inverse guy.
No. So this is the notation we are going to use. Y is sine inverse of x, or x is equal to sine y. Oh, sorry, y is the arc sine of x, and the y is the sine inverse of x. So that's the standard notation that we will be able to use.
Okay, thank you.
Any other clarification? Right, so in a similar manner, we can actually define the inverse of the cosine. And again, we are going to restrict the domain. So we have y is equal to the cosine of x. Again, it is not 1-to-1, but it becomes 1-to-1 if we restrict. So this one has an inverse. If we restrict the domain to 0 to pi. So if we restrict the domain to 0 to pi, in this case, its range is -1-to-1. And of course, in that case, like we did for sine, we can define the inverse of the cosine. So y belongs to -1 to 1. So for every y, let me put some more words here. Okay, so for every y in that range, there is a unique x belonging to 0, pi, such that x is equal to the cosine of y. Right, so in this case then, y has rather the cosine of x as an inverse if we restrict it to the domain from 0 to pi. So again, if I can draw the graph of the cosine, or maybe before I do that, let me just give you the following. So y is equal to the cosine of x has an inverse. Which we write as the similar notation, y is equal to cos inverse of x, or y is a cos of x. So this is how we would define the inverse. So again, if I may move to the next slide and try to draw the our graph. So you remember that for the cosine graph, what we have is the following curve. So it is so in the range 0 to 2 pi, you are going to have that particular curve. Right, so what we are saying is that you restrict this to 0 to 2 pi. So in this case, you are going to end here. So your graph now that you are considering is this particular graph. And you can see that if you were just to cut it from here, of course, here it continues all the way to minus infinity. But we are saying that we are just going to restrict ourselves to 0 to 2 pi, or rather to pi. And so the function that we get is 1 to 1. Now, again, we can draw the graph of y is equal to the cosine of x. It is actually also a reflection of the cosine inverse. So the cosine inverse graph is a reflection of the inverse. Right, so let me put this formally and properly. So the graph of y is equal to the cosine inverse of x is a reflection of the graph y is equal to cosine of x. Again, in the line y is equal to x. So you just look at the graph you have, reflect it in that particular line, then you get the graph of the cosine. So like I said, I'll not be able to draw this graph, or I'll not draw it, but you can know how they are related. Mm-hmm. Right, so for the inverse of the tan graph, we get it in a similar way. We restrict the domain of the graph. So here, if y is equal to the tangent of x, we can see that the values of y move from minus infinity to infinity. So y in this case belongs to this interval minus infinity to infinity. And of course, when we draw it, of course, we see that even the values of x will range from minus infinity to infinity. Now, to get the unique value of x for a given y, we still need to restrict the domain, or we restrict the values of x to a particular interval. So in this case, let's restrict x to the interval from minus pi by 2 to pi by 2. So the restriction, of course, is similar to that of the sine graph. So in that case, then, if you remember how the tangent graph was looking like, I'll be able to draw it in a few minutes. Then the function tan x will be 1 to 1 if we restrict x to minus pi by pi by 2 to pi by 2. Y is equal to tan x becomes 1 to 1. And of course, it is onto. And as an inverse in this case, and the inverse, of course, we'll write it in a similar way. So the inverse is y is equal to the tangent inverse of x, or again, y is equal to arctan. Shouldn't put a space, it's one word. So you have y is equal to arctan of x. Right, so what we observe in this case is that now, remember that we are swapping the range and the domain. So the domain of this function is now minus infinity to infinity, and the range is minus pi by 2 to pi by 2. So it has the same range as the sine function in this particular case. Okay, so I have less than 1 minute according to this watch here for Zoom. So let me end
Recording
the call,
stopped.
and then you just join immediately so that we can continue and look at what we have to see.
Anangali the like she wasn't convinced, so I had to say that.
Okay, so we can continue. So now I want to just show you, or remind you of the graph that we have seen before.
Recording in
which
progress.
is the graph of the tangent. So in this case, we know that the tangent is undefined at pi by 2 and also at negative pi by 2. So in this case, we are going to put in mind those restrictions, and that is the pi by 2. Okay, so there's undefined in that case, and then we saw that that was an asymptote. So our graph for the tangent was given as this. So that was the graph of y is equal to the tangent of x. So what we are saying is that we restrict ourselves in this domain, okay? Because this graph continues, repeats itself every after pi units. So we just going to restrict ourselves to this domain, and it is in this domain where the function is 1-to-1. So I was saying that you can see that the range of this function is minus infinity to infinity. So y is in that particular range, minus infinity to infinity, and x belongs to this range, which is minus pi by 2 to pi by 2. So that is how we restrict this particular function for it to be able to have the inverse. So the inverse now, like I told you, you just have to substitute, or rather interchange the variables in this case. It is also a reflection of this graph in the line y is equal to x, but then for the inverse, y is tan inverse of x as the domain minus infinity to infinity. That's the domain, and the range is now negative pi by 2 to pi by 2. So that is how these graphs are related. Right, so let's see if we can just look at one or two examples. Now, the other trigonometric functions like the secant, the cosecant, and the cot, these also can be defined in a similar manner by restricting the domain of this particular function. So now, let's see just a simple example. So let's find the exact value of y is equal to sine inverse of root 3 over 2. Okay, so remember that when we said y is equal to the sine inverse of x, this implied that x is equal to sine y. So this is what we have. So in this case, then what we get is that we have y is equal to the sine inverse of root 3 over 2. This then is the same as saying that root 3 over 2 is equal to sine y. Right, so what angles will give you root 3 over 2 as a sine ratio? That's the only thing that you need to find. So tell me, if sine y is root 3 over 2, what is y?
Sin 60.
Okay.
Did you say sine 60?
Y is 16 degrees.
Okay. So it means that y is equal to 60 degrees. So that's what you do. Or in radians, what is 60 degrees in radians?
Pi over 3.
So that gives you pi over 3. So that's all that we are going to be interested in, or that we'll be looking at when it comes to the inverse. I can give you another one. Let me call this number 2. What about y is equal to the cosine inverse of 1 over 2? So let's find the exact value of y is equal to the cosine inverse of y over 2, or rather 1 over 2. So in this case, y is the cosine inverse of half, implies and is implied by half should be equal to the cosine of y. So what is y in that particular case?
Sixty.
Right, so it is still 60 degrees. Right, so this is all that you need to do, and we are just introducing inverses of functions so that we can also understand how to get the angles when it comes to solving equations. And this is where we are going now. So for your practice, go and find the tan inverse of root 2 over 2. Right, so let's start by looking at what are known as the trigonometric equations. So we now move to trigonometric equations. Of course, these are equations that we solve whose solutions are angles in this particular case. So that is what we are going to be working with. So just look at a series of examples for us to be able to solve these equations. So let's solve the following. So solve for theta. So for theta, if theta lies between 0 and 360 degrees. So this is of course, we are restricting ourselves to 1 revolution. So let's solve the following. We have 2 times the cosine of theta plus 1 is equal to 0. Right, so let's solve this particular equation. So in this case, what you just do is just what you used to do when you are solving any kind of equation. So you have 2 times the cosine of theta plus 1. This will be equal to 0, implies that 2 times the cosine of theta is equal to -1. And so this then implies that the cosine of theta is equal to -1 over 2. So your duty now is just to be able to identify the ratio that you have and then know the quadrants for which the angles must lie. Okay, so in this case then, what we have is that because we are looking for theta, this will be the cosine inverse of -1/2. So tell me, in which quadrant is the cosine negative?
Second and third.
Sorry?
Second and third.
Second and third. So always remember that when you're looking at the cosine and the sine as an ordered pair, it looks like this. So it will be x comma y is an ordered pair, and the cosine is always the x coordinate, and the sine is always the y coordinate. So that's all that we need to think about. And then you are saying that the cosine is negative in the second and the third quadrant. Okay, so next look at the ratio. The ratio is 1/2. What angle in the first quadrant has ratio 1/2 for the cosine? I didn't hear that.
60.
60.
Yes.
That we are referring to is 60 degrees. But now we are in the second quadrant and the third quadrant. So in this case, the angle that we'll be looking at in the second quadrant will be equal to 180 minus 60 degrees. So that is the angle that we are going to have, which gives us 120 degrees. So that is in the second quadrant. We also know that in the third quadrant, the cosine is also negative. So in that case, what we have will be theta is equal to 180 degrees. So we are beyond 180. So we are going to add the reference angle, which is 60 degrees. And that gives you 240. Right, so you can see that the values of theta lie actually in the interval that we have been given, which is this interval here. So we see that 120 lies in that interval, and also 240 lies in that interval. If you move to the other quadrant, it means that you are now repeating the revolution. You come back to the second quadrant and the third quadrant. Is there a question on this one? I guess it's very simple, right?
Yes, sir.
Right, so next let's look at another example. Let's call this example number B. So we'll have the cosine of 2 theta minus the cosine of theta is equal to 0. Right, so we want to solve this equation. So here, when it comes to solving equations, this is where we now need identities. So you need to familiarize yourself with those identities and see how you can use those identities to solve your problems. So there are two arguments here. By arguments, I mean this. So you have theta and 2 theta. So for you to be able to solve this equation, you need to change either 2 theta to theta or theta to 2 theta so that you have the same argument, and then you should be able to use now what you know in terms of the inverse of a function. So what we are going to think about is an identity that involves the cosine of 2 theta, which gives us the cosine of theta and the other things. So how do we, which identity are we going to use for us to be able to change this? An identity that involves the cosine of 2 theta. Can someone tell me?
Two cos squared theta minus 1.
Okay, so tell me how the identity is like. How does it look like? The identity, tell me the identity that we are going to use. You said
2 cos squared theta minus 1.
2 cos squared theta minus 1. So this is the cosine of 2 theta. Right, so you remember that the identity that you should have, or that I gave you, is the cosine squared theta is equal to cos 2 theta plus 1 and divide by 2. Okay, so this is the identity that we are going to use in this particular case. And so we are just rewriting this so that we start with the cos 2 theta. So if we start with cos 2 theta, then what we get is that. So we are just going to substitute cos 2 theta by 2 cos squared theta. Right, so then the cosine of 2 theta minus cos theta is equal to 0 implies that 2 cos squared theta minus 1 minus cos theta is equal to 0. So this is what we have, and I want to rewrite this as follows. So you have 2 cos squared theta minus cos theta minus 1 is equal to 0. Now, theta there, so we are good to go. We can now try to solve this problem. But then I want you to look at this in this way. Suppose that A is equal to the cosine of theta. So if A is the cosine of theta, then we can rewrite this 2 cos squared theta with a different variable minus cos theta minus 1. This will be equal to 2a squared minus a plus 1. So that's how we can write this, so that now the equation that you'll be solving is 2a squared minus a plus 1, sorry, minus 1, not plus. Right, so you have minus 1 is equal to 0. So this is the equation you are solving, and then you see this as a quadratic equation which has some factors. So what are the factors that we are going to use here?
-2 and 1.
-2 and 1.
1.
So 1 is positive.
Yes.
Right, so we have 2a squared minus 2a plus a minus 1. That is what our friend is telling us, that this is now going to be equal to 0. And so the rest you can do. So you have 2a plus 1 times a minus 1. Right, so if we substitute back, so this is equal to 0. Let me just finish this up before I do any substitution. So this is equal to 0. This implies that a is equal to -1/2, or a is equal to 1. Right, so if we substitute back what a was, what we must have now is that the cosine of theta is equal to -1/2, or the cosine of theta is equal to 1. Okay, so those are the ratios that we have. So in this case, we are looking for theta. So it must be the cosine inverse of -½ or theta is equal to the cosine inverse of 1. Right, so I think we saw earlier, I think that is the one that we were looking at earlier, is it? Okay, so we have the cosine inverse of -½ We found those two angles. So I'll just write them as they are. So we have 120 or 240. So that is for the cosine inverse is of -½ The other is the cosine inverse of 1. So in this case, the ratio is 1. What angle gives us 1 when we are looking at the cosine?
It's 0.
0? Any other angle?
It is 60.
Okay, so remember the range you are in. Okay, so you have 360 also as part of the solution to this problem. So therefore, our solution now has the following. So theta is 0 or 120 or 240 or 360 degrees. So those are the solution for the particular equation that we have. Is there any question on this?
Yes, sir.
Yes, please.
Is it okay if you solve the quadratic equation without letting A be equal to cos theta? If you solve it direct?
Yes, you can solve it direct. There's no problem.
Okay.
But I wanted you to see it as a quadratic equation. I don't know whether all of you saw this as a quadratic equation when you were at this stage. Okay, any other question or clarification? All right. So if there is no question, then I wanted to give you another example, but I think let's look at it next week. Since it's almost 17 hours now, we can stop here if there are no questions or clarifications.
Recording stopped.
So please familiarize yourselves with the identities, because identities will play a very important role when it comes to equations. So you should be able to change particular functions from one function to the other. For instance, you can change the cosine to sine when it is appropriate. We'll be able to see this. And also the tangent to sec. So those are some of the identities that we are going to work with. So please make sure that you know those identities and use them whenever it is appropriate. Okay, so have a good weekend. So please let's meet on Monday and Tuesday. No, there's no Tuesday. We don't meet on Tuesday. So we'll meet on Monday and see what happens, because we should be preparing for exams starting from Wednesday. So all the best if you're writing an exam, and hoping you'll be able to come.
Thank you.
Thank you. Thank you.